Welcome to homework.
In this question, we have uranium-238 decaying, and its emitted alpha particle has a kinetic energy of 4.2 MeV, and we want to find the recoil, kinetic energy, and the Q value of the decay. So let's begin by writing our decay equation. So we have uranium-238. It's going to some daughter nucleus and an alpha particle or a helium nucleus, however you want to write it. So if we write down all our numbers, we're taking away 4 from the top, so we have 234, and 2 from the bottom, so we have 90. The atom with 90 protons is thorium, so that is our daughter nucleus. So we've been asked to find the recoil kinetic energy of this daughter nucleus. And to start this question, I am going to assume that the uranium nucleus begins at rest. So it decays at rest. So because we've said this, we know that the momentum of the thorium and the alpha have to be equal to each other, because we need to have momentum conservation before and after the decay. So the momentums need to be equal to each other. So we have that the momentum of the helium or the alpha particle is equal to the momentum of the thorium. So that's the first step we have. We then know that kinetic energy can be written as kinetic energy is equal to momentum squared over 2m. So we can say that the kinetic energy of the thorium, E thorium, is equal to the momentum of the thorium squared over 2m. But then we've just said that the momentum of the thorium is equal to the momentum of the helium. So we can then write that the momentum of the helium squared divided by 2m is equal to the energy of the thorium. We can then rearrange this equation to make p squared the subject, so we get that kinetic energy times by 2m is equal to p squared. So the 2 times the kinetic energy of the helium is equal to the helium momentum squared. So I'm going to sub that into this equation here. So we get 2e helium, mass of helium, over 2 times the mass of, these should be labelled as thorium, 2 times the mass of thorium. We can then do some cancelling. We get rid of our 2's and we're left with the mass of the helium over the mass of the thorium is times by the energy of the helium is equal to the energy of the thorium. So that is the equation we are going to be using, because we have been given the energy of the helium in the question. We have been told that the helium has an energy of 4.2 MeV. So now we just need to plug in our numbers into this. So usually when we've done energy release questions before, we've used the exact mass of the neutral atom. But in this case, we don't need to, because we don't need that level of precision. We don't need to go to the 6th decimal place. So we can just use the masses given to us. So we can do that helium has a mass of 4 atomic mass units, and that the thorium has 234 atomic mass units. And then we can times by the energy of the helium, which is 4.2 MeV, and we will get our answer in MeV. We don't need to convert anything with these masses because they are both in the same units. So whatever conversion we did, we would have to do to both of them, and that would cancel out anyway. So if we plug that into our calculator, we get that the kinetic energy of the thorium is 0.0718 MeV. 0.0718 MeV. So that is the first part of the question. Then in the second part of the question, we want to find the Q value of the decay. And the Q value of the decay is just the total kinetic energy. So that is the energy of the thorium and the energy of the helium. We've just found the energy of the thorium. So to find the Q value, we're simply going to add our energy of our thorium to our energy of our helium. And we get that the Q value is 4.27 MeV. And that is that question done.